Hi folks, so we're going to take a look at the solution to this optimization question, which hopefully will look familiar because you would have solved these types of problems back in grade 10 and 11. So here what they do is they give us the cost for producing a certain number of cones, and then they tell us that currently 500 cones are sold at $1.20 per cone. Okay, and if we decrease the price by 10 cents, 20 more cones will be sold, or alternatively, if we increase the price by 10 cents, 20 less cones will be sold, and we want to maximize revenue and profit. Okay, now I'm actually going to try to convince you not to use the method you would have seen back in grade 10 and 11, and I'll explain why. So what you would have done in back then is you would have used a variable. I'll use C since we've already used X for number of cones, and you would call this the number of price, say here we'll call it number of price decreases. Okay, it could also be number of price increases, and you would have said, well, the price for a cone, it would be, well, we're starting off at $1.20, and we're looking at decreasing the price, so we decrease it by 10 cents every time. So 0.1 times the number of times I decrease. So if I have one price decrease, I go down by 10 cents. If I have two price decreases, I go down by 20 cents. And then the number of cones would have been, well, 500. And what's happening every time I decrease the price? The number of cones I sell goes up. So plus 20 times the number of price decreases. Okay, and then you multiply the number of cones by the price, that gives you your revenue. Now, one reason why this is an issue is that the cost function is given in terms of number of cones. So that means you would have to take this expression and put it into that equation. Okay, so you'd end up with a 500 plus 20c cubed. Okay. Now, luckily with the chain rule, taking the derivative isn't so awful, but certainly does complicate the derivative a little bit. And the other issue, and the more important one, is that this is not how these types of problems are solved in, in university economics classes. Usually the variable we like to use is the number of items that are being produced or being sold. This is the variable which is almost always used to solve these types of problems. So not a bad idea to get used to working with the number of products as your variable, as opposed to this, pretty artificial variable of number of price increases or decreases. So is it possible to solve it using this method? Certainly. Okay, but I'm going to try to convince you to do otherwise. Okay, so the first thing we want to do is we want to start with A, which is just maximizing revenue. Okay, so how do we maximize revenue? Well, revenue is number of products times the price. Okay, so here the number of products that's our revenue. So revenue is the number of products, which is just X, and then what we defined as our price function or our demand function. So that means the price that we charge based on the number that we expect to sell. Okay, now here, since the number we sell goes up or down in a constant fashion, this is just going to be a linear function. Okay, so it's just a matter of determining an equation for this function. So this is the part that's a little bit more work than the other method, but then it helps us out because when we stick it into our cost function, when we're talking about profit, we're going to end up with a much nicer function. Okay, so here I'm just going to find the equation for this function here. Okay, so now I'm going to just find 2 points. So I know that when I sell 500 cones, the price is $1.20. Okay, and if I decrease the price to $1.10, I'm going to sell 20 more cones, so 520 cones, and now I've got 2 points, and I'm just going to calculate the equation of this line. Okay, so the slope is going to be, well, y2 minus y1, so 1.1 minus 1.2, so that's negative 0.1, and then 520 minus 500 is 20, so my slope is just equal to, let's get the calculator, negative 0.1 divided by 20 is negative 0.005. Okay, and now let's calculate the b value of this equation here. Okay, now I really don't want to work with point slope form because that's a little messier in terms of taking derivatives, so here I will use slope intercept form. Okay, so when y is equal to 1.2, x is equal to 500 times a slope of negative 0.005 plus b, and so b will just be equal to, okay, what do we have? We have 1.2, and to bring that negative to the other side become plus 500 times 0.005, okay, and that gives me 3.7. Okay, so my demand function, or my price function, is negative 0.005x plus 3.7. Okay, and now let's take all this and put it into our revenue. So revenue is equal to x times px, p of x, which is negative 0.005 x squared plus 3.7, and so that's just equal to, sorry, no squared there, I went ahead of myself, which is just negative 0.005 x squared plus 3.7x. Okay, now we already know that this is going to give us a maximum because it's just a quadratic with a negative leading coefficient. So in fact, don't really need to check anything here. Let's just find it. So find the derivative, and here we've got negative, and 2 times 0.005 is just going to be 0.01 x plus 3.7. Okay, and of course we want the derivative to be equal to 0. So x is just going to end up being 3.7 over 0.01. Okay. And so what do we get here? Well, we should know that that's just going to be 370, but divided by 0.01 just to check. And there we go, 370. Okay. Now again, even though this is a quadratic, we should just be checking. So it's, at 370. What do we have? This is a linear function with a negative slope. Okay, so here we see that it's going to go from positive to negative, so it's indeed a maximum. Okay, now we got to be careful because this represents the number of cones we have to sell, but what we want to find is the price that would maximize our revenue, and so the price, so when we give our answer, is just going to use our price function, so we just need to find P at 370, here, P at 370, which is just going to be equal to negative 0.005 times 370 plus 3.7, and that's going to give us negative 0.005 times 370 plus 3.7, and that gives us $1.85. Okay. So if we want to maximize our revenue, we're going to charge $1.85, so it's worth bringing down the price of these ice cream cones. Okay. Oh, sorry, made a mistake. Looks like we're increasing the price of the ice cream cones. Okay, because it started off as 120. All right, so the next thing we want to do now is determine the maximum profit. Now we can't assume that maximum revenue is going to necessarily give us maximum profit, okay? Because it all depends on the cost. So for example, maybe when you start producing more cones, you have to hire more people to produce those cones, and that's a big jump in cost to add someone salary, okay? So remember that the profit function, okay, is given by the revenue. So what you take in minus the cost, what you pay out to produce. Okay, so we already have the revenue function here. So that's this one right here. So negative 0.005 x squared plus 3.7x. Okay, and the cost function is not something we have to come up with. It's just given to us. So it's that up there. Okay, so that's going to be minus, and please don't forget to open these brackets. Okay, common mistake that'll ruin the whole problem if you don't use it. So 0 point, and I've got 1, 2, 3, 4, 5 zeros. Okay, so we start to see that when we're working with some real life examples, the numbers don't always work out quite so nicely. Okay, So let's simplify this here. So it looks like we're going to have negative 0.1234551 x cubed. Okay, and then minus 0.005 x squared. And then here 3.7 minus 0.1, so plus 3.6 x. Okay, now again, I'm only interested in x greater than 0 because you know, you need to actually, I guess presumably you could, you know, not sell anything and that might still maximize your profit if you're operating at a loss. So let's assume x greater than 0. And so now let's take the derivative. Okay, and this is pretty easy because it's just a cubic. Okay, so this is going to be 3x squared. So this number here is just going to be multiplied by 3. 1, 2, 3, 4, 5 x squared. And then here minus, that's just going to be multiplied by 2. So that's going to be 0.01 x plus 3.6. Okay, so clearly we're not even going to try factoring this thing here. So we're going to put it into the quadratic formula. So x is equal to negative b, so 0.01 plus or minus, okay, b squared, so 0.01 squared, minus 4 times a, which is negative 0.000003 times c, 3.6, okay, all over 2 times that number, so negative 0.000006, since we're multiplying by 2. Okay, so this is where you want to be very careful as you're putting this into your calculator. Okay, so let's do the addition first. So we've got 0.01 plus the square root of 0.01 squared. This is going to be plus 4 times 0.12345, 3 times 3.6, okay, and all that is going to be square rooted to the exponent 0.5, okay, and divided by negative 0.123456, and we see here that we have negative 3661, which we're not interested in since we're only interested in positive x values. Okay, so let's calculate the second one. So 0.01 minus, okay, it might have been actually worth calculating this, so I didn't have to do this a second time, but too late now. Okay, 0.01 squared plus 4 times 0.12345, times 3.6, all to the 1/2. Okay, and luckily that's negative, divided by negative 0.123456. And there we go. And this, of course, I will estimate, since we can't produce, you know, we're not going to produce a part of a cone. So here we've got 328. Okay, so that's a little more reasonable. And let's see that this indeed does give us a maximum. Okay, so here, if we look at P prime, well, I had my 2 zeros, including my negative one, so 328 is the only one I'm interested in, and we see that this is a quadratic opening downwards, so this is going from positive to negative, so this is indeed a max. Okay, but again, if we go back to our original question, they're actually looking for the price. So we needed to bring it up to 185 to maximize revenue. Let's see what happens if we want to maximize profit. So the price at 328 cones is equal to, okay, so let's go back here. So what do we have? We have negative 0.005 times 328 plus 3.7, and here we see that 206 is what we're going to be charging. Okay, so here 206 is what we're going to charge in order to maximize profit. Okay, so now based on, you know, the cost, once we bring in the cost, we see that maximizing revenue, maximizing profit are not necessarily the same. Okay, so to recap this thing here, okay, can you use your old method for dealing with these types of problems? Yes, okay, but it means that the variable you're working with is no longer number of products, which really is the more standard form or standard way of solving these problems. So what I do is I use the fact that the price function is linear, so I just find 2 points on the price function to find the equation, and then I apply all my principles of how one finds revenue and profit based on this and cost. Okay, that's it for this one.